Okay, in this question first, we have an object of 5 centimeter in length is held 25 centimeter away from a converging lens of focal length 10 centimeter. Draw the ray diagram and find the position, size and nature of the image formed. So first let's write what is given and what we have to find out. So that is the first step. So we have the object distance, which is 25 centimeter away. So it is 25 centimeter away from the lens, and according to sign conventions, we always keep it on the left side, so the sign of this will be negative. Next we have the object size, object height, which is h, and it is 5 centimeter, and according to sign conventions we always keep it above the principal axis, so this will be positive. Then what else is given? We have the focal length of the lens. Now the focal length is 10 centimeter, but is it positive or negative? How do we know? We need to check which type of lens it is. So this is a converging lens. So what is a converging lens? Converging lens is nothing but it is a convex lens because it converges the light rays. And convex lens always has the focal length on the right side, and according to sign convention, this will be positive. So now we have written down everything that we need to know. And what do we need to find out? So in order to draw a ray diagram, we need to find out its image position of the image, so which is represented by V. So V we need to find out. Then we need to find out the size of the image, which is nothing but H dash, and then the nature of the image, which we will come to know once we know the size and position. So let's start. The formula which we need to use is 1 by V minus 1 by U is equal to 1 by F. So this is the lens formula. So I'll just substitute all the things. Before that, I need to find out V. So I'll add 1 by plus 1 by U to add on both sides. So I'll take it to this side. So I'll get 1 by V is equal to 1 by F plus 1 by U. Now I will substitute the values. 1 by F is 1 by 10 plus 1 by minus 25. Take reciprocal. So I'll get this as 25 minus 10. I'll get 15 by 250. This is 1 by V. So V will be 250 by 15. 5 3s are, 5 50s are. If you solve this, I'll get the answer as 16.66 centimeter. Now something to keep in mind is everything is in centimeter, 5 centimeter, 25 centimeter. So the answer will also be in centimeter. So this is the image position. So what about the size of the image? We know the formula H dash by H is equal to V by U. So this is the formula which relates all these things in lens. Okay, now we need to find out image height. So H dash is equal to H into V by U. We know all these values, so we can substitute the values and find out H dash, which is the image size. So let's do that. So we have H, which is the object height, as 5 centimeter, into V is what we find out here, and that will be, I'll write it in the fraction form. Sometimes it is easier to calculate when you write it in the fraction form instead of decimal. And then we have the object distance, which is minus 25. Now if you solve this, you'll get the answer as minus 3.3 centimeter. So this is the image size. Now we have to at the end also draw the ray diagram. So in this, the object is 25 centimeter away from the converging lens. The focal length is 10 centimeter. Okay, so this is more than double the focal length, so it is beyond C. So I'll draw the object beyond C. This thing is 25 centimeter. And beyond C, the image, where is it formed? Let's draw that. So the image is formed between F2 and C2, which is nothing but 2F2. At the distance of 16.66 centimeter. And the size of the object is 5 centimeter. Size of the image is 3.3 centimeter. So this is how you draw the ray diagram.